Oh, good Lord. All right. All right, so I said I would run through these labs, so that is what we are going to do. So what I want to show you, let's run through we're going to start with the swamped. I apologize. I know this is all new stuff for everybody. So let's see here. Hopefully everybody's able to see this. So this is my circuit for a swamp seed, right? Let's verify it runs. Yeah, we got activity. Let me get rid of, but hold on here. Let us first get rid of this and just run it as is, right? So here's the whole circuit. So how do we verify it's working? Well, we should see activity, right? I do notice the way the orientation of my power supply is here. Blow this up a little bit. So we see current flowing, right? Now notice, all right. So you notice when as the signal alternates, see how it affects the current flow in this, and watch down here, see how it goes forward and then reverse, forward and reverse, and then we can even let's take a look at something here, okay? So let's get rid of that line there and let's put it here. Now, and again, way the current's flowing, right? On the one alternation, we spit back. Now, let's go ahead and move that, and then we'll move it. Oh, heck, where did I go here? Here. And again, same deal, right? But let's observe one more thing, if you don't mind. And get rid of so let's take the capacitor out, right? So now we just have basically, oh God, a common. Now notice the change here, okay? So now we do have activity. The current is flowing, but if we observe our waveform out here, as far as what we're putting in, we're not really getting much of an amplification effect. And the reason being is from the emitter side here, see how we have these like partial waveforms going on? What happens is essentially we get, this is what they call like harmonic distortion, right? So what's happening is we get negative feedback that goes in and literally dampens down our original signal. So what the capacitor attempts to do here, right? Let's go and put it back in the original state, is the capacitor attempts to alleviate that negative feedback, and that's why you get the flow like this. But notice my waveform now, all right, so now remember, we're putting in a sinusoidal, right? We got clipping, okay? So if we were to be basically look at it, we should be getting a sinusoidal in, sinusoidal out, right? That's what we've seen previous to this. So what is happening here, let's go ahead and actually change our period and draw this out a little bit so we can actually see what our waveform is all together. Now notice on the rise and in the run here, see how there's a slight amount, I mean, this is not a smooth sinusoidal, if you will. So what you're getting is still some distortion happening here, right? And a clipping effect. So, and this would work well if when we were trying to basically generate out like some kind of timing pulse, that kind of thing. There are applications for this type of thing, but really it's more of a learning exercise than anything. But like I say, observe, you can see what's happening on the alternations by the current flow. Now, in a normal DC bias, this thing should normally just be flowing through, right? But we're not getting that. We're getting reversed, basically on and off, if you will. And essentially, this is what we're looking for, right? Swamp C. What is swamped, right? Swamp overloaded, too much kind of thing. But what it is essentially it's an attempt. And again, if you remember from before with the DC, anytime we go with the emitter side, it's a beta dependent. It's not a really great amplifier, if you will. I mean, there are problems with it. Let's reverse up here. Let's check out what our Bodhi plot has to say. See, even in that, as far as the response goes, it's not a smooth filter, if you will. Right there. I mean, yeah, we're allowed to pass through on the 1 kilohertz range, but we don't have a whole lot of like bandwidth. What do we got? Our bandwidth essentially from actually not even 100 hertz. So we got a pretty tight bandwidth here before we start seeing distortion happening, right? So that when you start getting down into this range, that's your rejection area. And this is where the amplifier would not be working ideally. Really, we're locked in tight on this 1 kilohertz. So if we were to alter that frequency at all, we would start experiencing like more severe distortion, which we could even look at if we wanted to, right? Take a look at some of the other areas of this thing. And yeah, even before the capacitor, if you will. And what do we get on our output here? And there we go. So we can see sinking the ground that this thing is fluctuating literally all over the place. I mean, in one respect, you could look at it, okay, but again, really our only stability point, like very much so, is at the 1 kilohertz range. But if we look, yeah, our overall response, this thing's, you know, very much all over the place once we get into the 1 kilohertz range, you know. So overall, it's not a really good amplifier, but this is kind of really what we're going for. If you guys send me the screenshots and stuff, I'll go for full credit. I know on the questions I had, that was before we were really getting into the overall thing with this simulator. But yeah, when you go to THD is total harmonic distortion. See, essentially what happens is, and again, remember we're going, okay, so if we go common emitter side, see, what ends up happening is we're really working in what? The reverse bias region of the transistor here, okay? Trying to establish an amplification effect, which it does, but we have like clipping, and even on that output, there was, on the rise and run, there was some deviation to it. It wasn't a smooth alternation, if you will. And again, there are some applications where you could use an amplifier like this, but overall, if you were going for like, you know, signal replication type of thing where you wanted to have a smooth output, let's say like in the case of like sound or something like that, yeah, this is not going to get it. I mean, we could change the values and such like that, and again, notice my orientation, right? So there is my VEE, and remember, it's got to be a negative supply in. So in this case, the positive would go to ground, right? And there's my my function generator, if you will. So our AC signal coming in, right? And then our VCC has to be positive going in. And I mean, you can even look, and it's like, okay, does this thing work as intended, right? So what we could do, even as somewhat of, let me get rid of these waveforms real quick here, right? So my observation points or my probes, if you will, let's get those all out of there. Now let's go and check something out here, right? So let's get rid of the AC response of the circuit overall, right? Get rid of him. And we'll cut out this filter here as well. Okay, so now this would be a straight DC CE biased transistor, right? So let's observe, and this is a way you can check to make sure, you know, that your circuit, as far as the DC, because remember now we're going to DC bias these things, and essentially what does that mean for us? And I mean, one way to, a general way to look at it is we're turning the transistor on. We're turning on the circuit, right? So by injecting the DC in this case, now notice, right? See how the flow, we got the, even lists out what the current is. I could go ahead and put in a voltmeter and measure what my VCE and VBE are and all that. But we're getting a smooth current flow. So in a sense, this circuit works, right? I am able to activate, and this amplifier would work. And then what I would need to do is go ahead and inject my signals, right? So really, all these with the capacitors are for AC intents, okay? So let's stop that, back it up, and then we'll plug these back in, right? Got that in. And, that in. And that in. Now, let's observe. And you can see, okay, now it's running through. We can see, okay, here's my AC being injected in. I could change, we could change amplitudes in a sense, bring it down, make sure it is a small signal amplification. And then we can even monitor, okay, how did that change my output? And again, notice we're still experiencing clipping, okay? Now in this case, by bringing down the amplitude, it did smooth it out, but we are, clipping definitely here. But in this case, on the edges, on the rise and runs, we don't have really distortion, but what we do have is the clipping. So we're losing both the positive and the negative in that, right? So let's take a look what happens here if we move the position of this thing, okay? So now you notice, okay, we still are experiencing clipping, right? But not as severe. So the orientation of the capacitor, I mean, it would depend on, excuse me, what our purpose of this amplifier would be overall. And let's try moving it in one other spot, right? And now, what do we get out for our output? So now, if you will, now we have a smooth transition, right? So here would be an actual amplifier. So if we take, okay, what was my original input? So 400 millivolt peak to peak, right? So, and then we're getting roughly about, 4 volts peak to peak output. So that's smooth, right? I would consider that an amplifier. So the orientation of this capacitor is very important as far as what we're going for. So now you notice, okay, let's click that in. See, we go into that position and oh, look, now, yeah, we're back to our clipping. Okay, but notice the amplitudes here. So in a sense, we're really pushing this thing to its limits. But again, we don't really have any distortion effect. But let's look one more time and put it back to the original position, right? So now let's just take a peek at some stuff. And again, we're getting, we are getting a severe clipping. Notice our regions here, and that's our limits, okay? So if I did want to make something where I'm getting like a timing effect or a pseudo square wave, if you will, okay, that would be something to go with. But yeah, the orientation of that capacitor does matter a lot. But let's take a look. All right, let's stop the waveform here, back it up. Let's change our value. Oh, it's down to 10. Now let's look at our output. Overall, it really doesn't change a whole lot with the circuit. Notice we're still going. See how the current reverses and with the alternations of the signal, right? And essentially, that's our swamped CE amplifier. Okay, and I'm gonna, let's see here, stop that.